Snakes don't have friends, Chris.
That's not so bad.
They don't feel what we would call affection.
Hi there guys, I'm Chris Boden with today's Captain's Vlog. It's Saturday, May 17th, 2014, and it's 13:04 hours, and we're here with Trouble, who drug us down here.
On occasion I've been known to do so, yes.
Tell them where we are and what we're doing.
You are at the Kent Career and Technical Center. This is the Commons area, and tonight we're partnering with Jack and Jill of America and the Geek Group and Girl Scouts and other groups that are around here. You'll see them throughout the night. And this is a STEM fair for families within the community that maybe the kids are interested in it, maybe the parents are interested in it. Whoever wants to come and check it out, they're welcome to join us. So we're hoping to have some fun.
And who are you?
I am Avery Nkuba. I am a STEM consultant here at the Kent Intermediate School District.
Cool.
Yeah.
And you're the guy that drug us down here.
Well, hey, you know, I get along so well with everybody I've met from the Geek Group that it really kind of wouldn't be as STEMmy for me if you guys weren't here. So
well,
I love having you around.
We like to come down, and I'm going to show some people your other toys you got. You got to tell us the story behind it.
We'll go check it out.
You want to? Let's go here. Because this is cool. You got a jet engine in the lobby.
Yeah, jet engine in the lobby is not normal for most folks, but at the Kent Career Technical Center, it kind of is actually. This one does not reside here. Normally it stays at a place called the Kent Aviation Center, which is our hangar located at Gerald R. Ford International Airport in Kent County, Michigan. So this is a J79 by General Electric, and it did power aircraft like this, such as the F4. It was the first jet engine that was designed for a specific aircraft application. For its install and removal. You can see it's on these rails. This is a transport and install rail, and it has to be housed on this. And what would happen is when they needed to do a quick engine change, they'd pull up behind the aircraft, an aircraft similar to this, and if you look right back here, you can see the directional cone that you see on the back of the engine back there. So what they do is they wheel these rails up, they clip them in place to the back of the airframe, and they roll the engine out after they've unhooked all the buttons and switches and wires and hoses and things like that. So intake, compression, power, and exhaust. This is a can annular type burner can, and then once we shoot the fuel in here and it ignites, comes across all of our turbine wheels back here, multi-stage, 3-stage in this case. That's where the jet engine ends on this specific aircraft. The rest of that is afterburner. What you see here are all of the attach points for the nozzles inside, and all we do is we shoot additional fuel in right there, and the exhaust coming out obviously is hot enough to ignite the fuel, and the rest of this is afterburner. Literally burns after where it's supposed to for combustion purposes within the engine. So that's a J79 by General Electric, decommissioned military engine.
Thank you, sir.
Yeah.
And I know everybody on the blog is waiting for me to do this, so here you go. There's a look up the butt.
You got enough light?
Yeah, actually. To protect the fingers of the wee precious children, they blocked it. There's a thing in there, so we can't turn it, which is just sad. But here, you can take a look in the snout. It's pretty badass. We'll be back. This is the Geek Group's Farnsworth first user. It's electrostatic, inertially confined fluid. What you see in there is all pure plasma. It's purple right now because we're just pumping a vacuum. It was filled with air usually. We pumped a vacuum on it, so the nitrogen left in there is going to get that purple glow. But it's rock simple. It's an electric motor and vacuum pump with chambers, and simple metering, simple power supply. It's all about the grids. This is a star in a jar. Perfect.
Thank you.
High voltage, like sign lit up in your hand. Just think about that for a second. You have a neon sign in your hand, lighting up. Right on top of here, there's a ring right there. See it? Watch the ring. Watch the ring.
Snakes don't have friends, Chris.
That's not so bad.
They don't feel what we would call affection. It's going to shatter in her hand, and then we're all going to have a bad day. Be careful actually touching it.
Inside a solid concrete room, big steel door and all that. Now watch this. Come on inside. Come on inside. It's gonna be cool. This is inside.
I don't trust you.
Big steel door, like 1.5 inches thick, right?
Oh, boom.
Now watch this. Listen really close. This measures radiation. You've seen it measure radiation. Now you're not radioactive. I'm not radioactive. What's that?
The natural radiation that's in the atmosphere.
Yes, but where's it come from?
Where's it come from? Heavy dense atoms in the air.
No.
No.
That's cosmic rays. That's cosmic rays. This is not. This is coming from stars that have died and exploded out in space. This is where we get supernovas and things like that. When a star dies.
Yes.
Okay. Real simple. You take a whole bunch of hydrogen gas just floating around in space. Most prevalent substance in the universe, hydrogen, right?
Yes.
One proton, one electron. Rock simple. Big ball of this hangs out. Well, if you have, think of space like a big trampoline. Okay. And the bigger an object is on the trampoline, the bigger a dent it makes.
That's right.
That's a gravity well. That's how space-time works, right?
Yep.
So if it's in a dent, if you got a big planet on your trampoline and a little dude comes by, he's gonna, once he gets so close to you, he's gonna fall in. That's how gravity works. That's why we're stuck to the ground.
I
right?
get it.
Okay. No matter how tiny something is, even down to a single hydrogen atom, it has gravity. It makes a little tiny dent in the trampoline, but it makes a dent.
I get it.
So it's just enough to pull in another hydrogen atom. Now you got two. And if you got two, then grab a couple more. And it grows. And you do this over like billions of years, and you get a hell of a lot of them. And now you get enough of them that they make a pretty big dent. And the tighter they get, the bigger the dent, because it gets more focus, right? Okay. If you take 1,000 pounds of little pebbles and you spread them all over the trampoline, it doesn't make a really big dent. It evens out. But if you put them in a pile, boom, right? Okay. Same thing with atoms. Same thing with atoms.
Same thing.
Now you pile these all together, and they squeeze together so tight that they get hot. The energy goes up because all this gravity, right? And it actually squeezes so hard that the hydrogen atoms can't stay apart anymore, because the hydrogen atom has its little proton and a little electron whizzing around in like a cloud, right?
Yeah.
Well, the two clouds squeeze together so hard that they bond.
They bond.
And now you don't have hydrogen anymore. You have helium. Because you've got two protons and two electrons. So you made a new thing. You've just made helium.
Yes.
You didn't have helium before, but now you got helium. Okay?
Well,
and when they do that, the two atoms fuse. Right?
Yep.
That's fusion. And you made a whole new thing. So what you did is you gave off a lot of heat, which gets all the other ones excited. So they start fusing, and you're giving off light, you're giving off radiation of all kinds, and that's how you get a star. So now in the star, you're turning hydrogen into helium.
I'm with it.
And when it runs out all the hydrogen, it gets really bloated for a little bit, okay? And it twitches and it pukes a little bit, and it gets really, really big. They turn red. It turns into what's called a red giant. It's what our sun will do, okay? And that will suck. That will suck really bad. Because all the inner planets, like Mercury, Venus, Earth, we're screwed. We'll be, right now where you are, is 93 million miles away from the sun. Right? We will be inside the sun when the sun. Don't worry, that's like 5 billion years.
This isn't like
on Tuesday. It's a lot.
Yeah.
But what it does is it makes all these heavier elements. Okay, you make hydrogen, then it makes lithium and oxygen and nitrogen and all the things that you need
from hydrogen.
All starts out as hydrogen.
I'm with it.
Okay, you just start. And that's where. Okay, now this is the part that's going to mess you up.
All right.
The star will die. They all do. Okay, our sun is like a third generation star. Really, the universe has been around that long. Okay.
Okay.
So when our star dies, it'll explode all this stuff out into space.
Okay. Burp it up.
Yep, it just and it's out there. Okay. And depending on how big the star is, depends on what happens when it dies, and that gets really cool.
Yeah.
Okay, because not only is it making molecules, and we'll come back to that because I'm going to freak you out.
Yeah, I'm with you.
But if the star is kind of big, when it crunches down, it'll form like a white dwarf. And then and that's where everything's packed as dense as you can. Okay? And then you can go up a notch where it'll pack so tight that it'll overpower the nuclear force. And you end up with just a big, super tight, dense wad of neutrons, and that's called a neutron star.
Okay.
And that is more heavy than you can possibly. If you had 1 teaspoonful, okay, like a sugar cube
of a
neutron star, would weigh more than every person on Earth. If you had a tablespoon of a neutron star, would weigh more than Mount Everest.
Wow.
It's that dense.
Okay.
And now here's where it gets really cool. If the star is really big, really, really big, and it collapses down, even the nuclear force can't push it out, because that's why you ever notice how stars are always balls?
Yeah.
Well, the reason why is the bubbles are balls too. For the same reason. A bubble and a star are shapes that are in balance.
Okay.
Inside a bubble, you have air pressure, right? Because you blew the bubble.
Yeah.
But you have the atmosphere trying to crush it down. Okay, it's got to balance out. The sphere is the shape of balance.
Okay.
Well, a star works the same way. You have this giant nuclear explosion happening, but you have the gravity, because it's in a dent, we're on a trampoline, trying to crush it down. And the shape of balance is a ball. That's why stars are balls. So if you have so much stuff, and this is a hell of a lot of stuff, okay? If you have so much stuff that even the neutron, the nuclear force, can't keep it apart, it crushes so tiny that it doesn't exist. It's gone.
Total annihilation.
Total annihilation. But maybe
But you just told me the neutron was so heavy.
it makes a dent. It's so heavy. It's so dense. Okay.
And you,
well, remember how we spread it all out? We make no dent, but we make it a tight focus. We make a big dent.
Yep.
What happens if your dent pokes through? Just it's gone. Because the gravity goes up even more the tighter it is. So you add more stuff, and it like sucks in other stars and stuff.
Oh my goodness.
Okay. This gets so dense that there's so much gravity, the hole's so deep, that light can't get away from it, so you can't see it. So you it's a black hole. That's what a black hole is. You've got this really big hole. It's a big dent in the
trampoline.
That's how it works. Now here's the coolest part. This is going to mess you up. All right. Now, I don't know if you're aware of this. This might come as a shock to you. Big and black.
Yeah.
Okay, I know. It just... And now, here's the weird one. I'm as white as they get. Now, why are you black and I'm white?
I don't know.
Stars.
The stars?
Stars. And here's the coolest part. You're made of stars. So see. I don't know about this guy, but he's made of stars. Okay, all the molecules, everything on a periodic table comes from stars, supernovas, all that, right?
Uranium, all of them.
They explode, they condense into planets. Okay? Big giant chunks of stuff floating around in space. It condenses into planets. Yep, and there's all kinds of stuff happening. There's really cool complex chemical reactions, takes tons and tons of time. Now, we're going to go full circle, we're back to this. Okay? Now, if you take biomatter, and it's evolved into life, and it's growing, okay, and we started out as, but before you, like fish.
All right.
Fish.
All right.
You started out as fish, okay, and it crawls out of the ocean, and then, you know, and then you get dinosaurs, and all these little creepy dudes crawling around in rocks, okay, that was us.
That was.
Okay? Asteroid came, killed all the dinosaurs, evened out the playing field, we got to grow up a bit.
There you go.
Now, over all this time, this is happening. And these little cosmic rays shoot through your nuts. Right now, blasting your nuts. Happens all the time. And this introduces, at the tiny molecular level, down into DNA, inside your sperm, okay, because sperm are really tiny.
Yeah.
Okay, and inside the sperm, wrapped up really damn tight, okay, is a little itty bitty DNA molecule.
Come on.
Yep.
It is.
And it looks like a ladder, right?
That's right.
So
the helix, the double helix.
This, no, you only got half of it. But this, she got the other half.
That's right.
And that's where he came from. But that's a much more fun story. We'll get into that later. But this happens over billions and billions of years, right?
Yes, sir.
And this is random. And it happens all the time. If we went down in Mammoth Cave, okay, like a mile underground, go down in a mine shaft, you'll still get this. From space, blast right through the earth, doesn't even slow down. Gives no shit at all, it's there, okay? And that little tiny bit of random is why you have tall guys and short guys and fat guys and skinny guys and white guys and black guys and it's change, man.
Whoa.
Yeah. It's not so much with white and black, that has a lot more to do with latitude and evolution, but yeah.
Still.
But yeah, that's where it comes from.
And we're in this concrete room and we're still reading it.
This is from space, in a concrete room.
That's what I'm saying.
And you could go, you could do this at home. You can get a Geiger counter. You can buy these online for like 20 bucks. You get a Geiger counter. You go down in the basement of your house. You go like find a bomb shelter. Go downtown. You still see the old signs, bomb shelter.
Yeah.
Go down in a bomb shelter, which is supposed to be radiation proof. And this gives no shits. None. It works.
You know the bomb shelter by the East Congregation of the Church? He's saying if we went down there with
If you went down there with this, it would work. It would do exactly the same as this. Wouldn't slow it down a little bit.
That's right.
If you guys weren't in here with me, I would be the smartest man in the night. If you weren't in here, because I was going home like, guess what I know?
But this is what we do at the Geek Group. We get, because right now you just learned all kinds of new stuff about science.
Man.
This is the coolest part. Okay, you're made of stars, man.
Can you believe that?
Yeah, I'm really sure on this. Science on that one's pretty solid.
Okay.
You're made of stars.
No, well, neutron stars. I gotta talk to you about it.
No, I'm like,
No,
what?
it's just, I'm trying to figure out how we're gonna power ourselves. I'm thinking.
Don't need to.
We don't need.
Well,
What's the most
obviously,
prevalent source of energy on the planet?
the sun.
Solar.
That's why we're
It's
gonna
there.
power
It's
that.
there.
But I mean, later on.
Right now, outside my parking lot.
Right.
Okay, but it's not my problem.
It's not.
But you give me okay. The ignorant was our problem.
It doesn't matter.
It doesn't.
4.7 billion years from now, the options are really simple. First off, we're going to be long gone.
Yeah.
Long gone. Because if you just went with asteroids alone, the human race will not live that long.
Okay.
The best chance we have is we're not going to be here. We're going to be somewhere else.
Okay.
Our planet will die. All planets die. All stars die.
It's inevitable.
It's inevitable.
When we leave,
Which
we'll probably
is what
slap
you
a bunch
showed
of
me.
planets
It's-
into our planet.
it's
The
over.
sun's gonna
The
die.
sun will die,
If we
and
don't die
it'll
first,
make
we're
new
dying
suns.
then. You
There's
know?
new suns made every day.
That's okay.
It's so big you can't comprehend it. Okay, right now,
Right.
I need something to draw.
Yeah.
Come here, come here. I got to draw you
Oh,
here.
this is good.
I'm gonna mess you
What's
up.
your name again?
My name's Chris. Alright, now, if you think, we talked about atoms, molecules.
Yes.
Now, in an atom, if you have like a hydrogen atom, okay, let's say you're the proton at the center of the hydrogen atom.
All right.
Now, to scale, right?
Yep.
Okay, so this is your little proton. It's the size of your feet. How big's your electron and where's it actually? Okay, this is going to mess you up. Let's say you got a P this big, and that's your hydrogen.
Then if I'm the proton, my electron, you're too far.
Your electron would be about the size of a period on a piece of paper.
Protons.
About where I'm at.
From my proton?
From your proton. Okay. The cooler thing than you are made of star stuff, you are like 99.9999999% empty. You're way more nothing than you are stuff.
Really?
The amazing thing is that you can't just pass things through. You can't just walk through walls because if you, by that logic, you can't because of nuclear forces. But in space, all right,
Ah, like where there's no up and down, no left and right.
it doesn't matter.
Okay.
In space, they call it space for a reason because there's a really long way between stuff. Okay, so let's say you got same distance, okay, and it's like Earth to the sun. Okay, now at the speed of light, that takes 8 minutes to get there. Okay, 8 minutes. If the sun went out right now, you wouldn't know for 8 minutes.
8 minutes.
The really cool thing is we'd still have gravity. Figure that one out. For 8 minutes.
Ah,
Yeah. After that, no more gravity.
More gravity.
But let's say it's you to the sun that far. Okay. Now we shrink that down, which is like 93 million miles. We shrink that down to this big. How far away is the nearest star? Downtown. Yeah.
It's
Downtown. It's that far away.
making it relevant.
And if we take the nearest star and we collapse all those in, and now you have our galaxy, the Milky Way.
Milky Way,
Okay?
yeah.
And if you look at the Milky Way, it looks like a big swirl. We're out on one of the outer arms. We're in this little. We don't really matter.
We don't matter.
Okay, we're out. We're out. Okay. So you got our galaxy. Now, galaxy. That's like 100,000 light years across. 100,000 years at the speed of light. The sun is 8 minutes away. It's 100,000 years to get. Yeah, it's big. Now that's just our galaxy.
It's like 8 Plutos away. Is what you're
No,
saying?
it's a lot more than 8 Plutos.
Even more than that, so I
Yeah,
can
it's a
make
lot.
it
It's a
count.
lot.
Okay.
It's unimaginably big. So that's our galaxy. That's, let's say, round numbers. That's 100,000 stars just in our galaxy.
Okay.
Suns.
Like this every day.
Every one of those suns has its own planets, and they have their own moons, and they can have their own people on them. They can have their own
They
life.
have to then.
They have to. Well, they don't have to, but
I
Drake's
think they have
equation
to.
says they probably do.
Yeah. Why can't we reach them?
Space, man! It's far away!
Back to the
It's
point.
space!
It takes too long.
Yeah, it takes too long. And how many times have you walked past ants? Just walking down the sidewalk and you see ants on the sidewalk. Do you stop and say hi? No, because they're stupid. They're just ants. How do you know they don't think of us like ants? Because if they're smart enough to do interstellar travel between stars, they're looking at us and they're like, they're still killing each other. They can't even get along.
Give me some. Right. It's just like me to an ant. It's like, dude,
Same thing.
the people who can reach us don't have time to stop here.
No.
This is
And that's just one galaxy. Our galaxy
Exactly.
is part of a whole cluster that we call the local group.
the local.
Okay, that's the local group. The local group is like,
multiple galaxies.
which is tons of galaxies. It's like half of them. Okay.
There is other life out there. We just can't get to it.
And then out of that, galaxies. You know how when you go out and look at the night sky and you see about 5,000 stars?
Stars in the night, yeah.
Imagine if those were all galaxies. There's more than that out there. There are hundreds of thousands of galaxies out there. And we don't even know how far it goes.
That's why it's called space.
It's space. It's just, it's
it
big.
is.
It's unimaginably big.
You can't.
And when you realize all that, you realize that you're made of stars and all this, all the bullshit that we do to each other, you realize how stupid it is. Because it's bigger than that. Exactly. Your whole mind, just a guy.
And you tell me you guys get together at the deep,
We hang out and build cool stuff. Because this is what matters. This is how you learn. This is how you grow.
and me and my son will come hang out with you guys.
Yeah. Check it out. Are you there? Yeah, we're there all the time.
I'm excited, man. This time around, I have the aptitude, but didn't have the backing. Now, me and her, we made, the double helix. And our son, we have the backing, and he has the aptitude.
Get him down.
I got to keep him around.
The kid knows about neutron stars. He's doing all right. Come on down and learn how to make robots and rockets and all kinds of fun stuff. That's what we do.
All right, Chris.
It's a pleasure meeting you.
That's Rodney. It's a pleasure meeting you too. Thank you so much.
Oh,
Oh, man. Oh, you know what? Just, if guys, if they weren't in that room with me tonight, I would have been Mr. Wizard at home. I'm going to still do it anyway.
I'm used to being the dumbest guy in the room. You ought to come hang out with the smart guys.
I'll be there.
I got nothing.
Wow.
That's awesome.
I want to thank the Kent Skills Center for letting us come out. I got to make some new friends. This is a jungle carpet python. He's just a little guy, but he's cute. You like the leather jacket? You like the hat? You want to be a hat band? Yeah, you want to play in my hat band? I got a position just for you. Yeah, that's quite the lecture sport in there. Alright guys, we'll be back. I gotta head back to the lab and see what insanity's going on out there. He likes the camera. You're aggravating the snake. He's gonna bite you. I'm gonna laugh like hell.
If only it would focus on him.
Hi. How you doing? You gotta go back to Dad.
Just trying to hang on to something.
Yeah.
They used to be in the tree.
He's going down his
I can't help it. I don't want to fall.
Thank you, sir.
You're welcome.
You guys have fun.
You too.
Well, what school are you with? I want to.
East Kentwood.
This is East Kentwood High School.
High School.
And you guys have a serious herpetology.
We have a herpetology, aquatics, aviary, we got a macaw.
Now you got to get an apiary. That's the next thing. You got
That
to
would be it.
Yeah.
When they get done renovating our room this summer,
That would be cool.
maybe
It was a pleasure meeting you.
It was great to meet you too.
You have
as well.
fun.
You bet.